Okay, we have e to the power of s and sine as a function of t minus s. Okay, where t is a constant. Okay, so this is integration by parts, and we have to pick our u and dv. And I'm gonna pick u to be sine with t minus s. Right? And the reason why I'm picking sine instead of e, in which in this case you can actually do it either ways, is because e to the power of s, the s is just a nice simple s. Very, very easy to integrate. This right here, if you were to this has a minus in front of the s, so we actually have to chain it by -1 every time we differentiate or integrate. And I'm comfortable, most of us are more comfortable with differentiating, so I pick it to be u so that I can differentiate it instead of integrating it. Okay, so having said that, let's differentiate the u. You get a cosine of t minus s, chained by the derivative of t minus s. Remember, t is a constant, so we get a negative here, negative ds, and v stays the same, e to the power of s. So let me call this a here. So then we have a, okay, so u times v, so e to the power of s, sine t minus s. Okay, so subtract, but there's a negative here, so it's going to be plus e to the power of s, a cosine t minus s ds. Okay, again, same thing. Let's let u again, this time again the trig, let's pick the trig to be what we're going to differentiate, and dv to be e to the power of s ds. So here we get a minus sine t minus s, but if you differentiate t minus s, you get another -1, so you get plus, and v stays the same. Okay, so we have a, okay, so this part right here, u times v, so e to the power of s cosine t minus s minus, okay, e to the power of s sine t minus s, okay, ds. So that right there, you see, is exactly what we started from. So we can change that to a, okay, and bring that to the other side by adding both sides by a, and we get 2a. Okay, finally, the integration that we want is half, okay, half of, let's factor out e to the power of s, e to the power of s, sine t minus s, cosine t minus s, okay, of course plus some constant.